Hello everyone and welcome to Tuesday the 12th of January's virtual maths lesson. So following up from yesterday, we're going to be continuing our learning about percentages. What I'd like you to do first off, and is similar to yesterday, we're going to do our starter activity. So you've got 3 questions here from various areas of maths. Some of it we will have covered recently, some of it we'll have covered previously, some of it you might have done all the way back in year 5, so you'll have to have a real think. Number 3 in particular takes some thinking about. Think about it logically. What I'd like you to do is you're going to pause the video in a second, have a go at these on a piece of scrap paper, a whiteboard if you've got one, just edit anything you've got around just to get your brains warmed up. Right, give it a pause, have a go, and unpause to come back when you're done. Okay, we should be back. We should have had a go at all 3. Not saying you need to have completed all 3, but we should have had a go or at least think about all 3 of them. Now your answers for these. The first one, Ron and Eva each make a 3-digit number from these digit cards. We've got 3, 6, and 8. Ron makes the largest even number possible. Now we know even numbers have to end with 0, 2, 4, 6 or 8. So there are 2 options for the number that goes into the ones column. We could have 6 or 8. Now if we put 8 in there, that means 6 would be our biggest hundreds number, but if we put 6 in there, 8 is our biggest hundreds number. So it's 8, 3, 6. Okay. Eva makes the smallest odd number possible. So 6, 8, 3, there's only one odd number in those digit cards, so the 3 has to go in the ones column, and then it's about the order you put the 6 and 8 in. 6 being the smaller number needs to go in the hundreds column. What is the difference between their numbers? Difference is another word for subtract or take away. So we take the biggest number we've got, take away the smallest one, and we're left with 153. The second one, all the fractions that are greater than 1 but less than 2. So all of these fractions are top heavy or improper, so they're all going to be bigger than 1. To be less than 2, the number on top must be, okay, must be less than double what is the denominator. Okay, so we've got 5 as a denominator here. Double 5 would be 10. 12 still bigger, which means it's going to be bigger than 2 lots of that 5. Here we've got 6. Double 6 is 12. Oh, 12's on top. That means it's exactly double, which means it's exactly 2. It says less than 2. So we cannot have this one as an answer because it's exactly 2, not less than 2. Then we have this one here. Double 7 is 14, which is bigger than our denominator when doubled. So therefore it's between 1 and 2. So that's fine. And this one again, double 8 is 16, bigger than the 12. So it's between 1 and 2. So these are the 2 that were greater than 1 and less than 2. This bottom one took some thinking about because there were 16 squares. Okay, but what we have to notice is that the squares are almost cut in half when they're shaded. So if each square is cut in half, that means each square, there are 2 parts of it. If there are 2 parts in every square, that means there are going to be 32 parts. So 32 parts would be our denominator. And then we just count how many of those half parts we've got. 1, 2, 3, 4, 5, 6, 7. 7 over 32. Right, that should be us warmed up with our starter. Let's move on. So our learning intention today is to that's a mistake by me, but to convert between percentages and fractions. So yesterday, we converted from fractions to percentages. Today, we're going to go the other way, but we're going to use a similar method, not the exact same method, but a similar method. So again, our star words, fraction and percentage, convert, changing from one form to another, equivalent, so equal to, and denominator, again, is going to be important, the bottom number of our fraction. So yesterday we looked at how to convert a fraction to percentage by making the denominator 100. Today we're going to look at how to do it the other way, and we're going to show equivalent fractions in their simplest form. Okay, so we're not going to just show the denominator as 100, we're going to simplify it using the skills we practiced last term. So let's focus on 20% initially. We're going to use a similar method just like this. We put the 20 as the numerator because we know when the denominator is 100, the numerator is a percentage. So if we put 20 as the numerator, we can put 100 as the denominator. So we've got 20 over 100. Now that in itself is converted. That technically is a fraction. But we did say, and it will say in a lot of questions we come up against, that we need to simplify those answers. So we need to think what goes into both 20 and 100. We know 2 goes into both, and we could simplify by dividing through by 2, but that would mean we'd have to simplify again. The quickest way to do it is to go through and work out what is the biggest number that goes into both. 2 goes into both, 5 goes into both 20 and 100, 10 goes into both 20 and 100. I'd have been tempted to go with 10, but just take a little moment, have a think. 20 goes into them. 20 is the biggest number that goes into both. So then we ask ourselves, the numerator first, how many 20s go into 20? 1 lot of 20 goes into 20, so we write a 1. Then we look at the denominator. How many 20s go into 100? 20, 40, 60, 80, 100. 5 lots. So I've got a new numerator of 1 and a new denominator of 5. So we can simplify 20 over 100 to 1 over 5, which is 1/5. We cannot simplify that anymore because there is nothing apart from 1 that goes into 1 and 5. So therefore we can say that 20% equals 1/5 in its simplest form. So the way to do it, percentage, write it over a denominator of 100 and then simplify it. Easy as that. What I'd like you to do is on your whiteboard or your bit of scrap paper, I would like you to have a go at converting this percentage, so 40%, into its equivalent fraction in its simplest form. So use the method we've just done, put it over 100 and then simplify. So if you give the video a pause, have a go and then come back afterwards, unpause, and we'll carry on with the answer. So pause it now and have a go. Perfect. Right, let's move on with our answers. So 40% equals 40 over 100. Great way to start. What goes into 40 and 100? 2 does, 4 does, 5 does, 10 does, 20 does. 20 is the highest it goes in. So how many 20s go into 40? 2. How many 20s go into 100? 5. So therefore we put the 2 as the numerator, the 5 as the denominator, 2/5. 40% equals 2/5 in its simplest form. And we can always check that by saying, right, what goes into 2 and 5 apart from 1? Nothing. So therefore we've got it in its simplest form. Hopefully we got that, or got some of that method right at least. What you're going to do for me now is your task again is set on Mathletics today. So you're going to log on to Mathletics and have a go at it. Just going to give you a warning though, some of the questions are tricky today and will require some real thinking about, because it's going to ask you to convert both ways that we've practiced over the past couple of days. And also to try and stretch your thinking, it's going to throw in some mixed numbers as well, which we've not talked about because I want to see what you remember and if you can use them. So for each question, you'll have to select whether your answer needs to be a whole number, a mixed number, or a fraction. So have a look at this one. It would give you 70%. So we know if we're going to convert that to a fraction, it's not going to be a whole number. So we're not going to click this box. It could be a mixed number, but it's not really going to be because it looks like it should be an easy one to convert. So we'd click fraction and write what fraction it would become. Sometimes you'll have to do the mixed number, sometimes whole number. Don't panic if you find it a bit tricky. Just do your best on it is all I want. Once you've had a go at your Mathletics, you're going to come back and we'll carry on and do our reasoning question. So if you pause the video when I say, go and do Mathletics and then come back and unpause. I would possibly suggest going back and watching the example I went through again, just to make sure you've got a method before you get going. So pause it now and have a go at your Mathletics, please. Right, hopefully we are now unpaused. We've had a go at Mathletics and we're not pulling our hair out at the questions. So let's move on and apply it to a reasoning problem. Take some thinking about, but it's gettable, this one. And in an exam situation or in a test situation, this would probably be about a 2-mark question. So it's a quick 2 marks to get. Amir thinks that 18% of the grid has been shaded. Dora thinks that 36% of the grid has been shaded. Who do you agree with and explain your reasoning? So what I want you to do is I want to solve this in your home learning books. So I want you to do your best at using the method we've used. A hint I will give you, the method we've used, think about the denominator we've been making. Okay, think about the denominator Amia is going to have made, and think how Dora might have used what we've done, the denominator we've done, to get her answer, and we'll see who you think might be right. So pause the video, have a go, and then unpause, and we'll go through the answers. So give it a pause, crack on. Okay, hopefully we're back, and we'll go through the answers now. So Amir has counted the numbers shaded and the total number of squares and made a fraction. So he's counted 18 green squares, and he's counted 50 squares in total. So he's put the 18 as the numerator and the 50 as his denominator. However, we know that a percentage must be out of 100. We make the denominator 100 in our method. This one's 50, so cannot be a full percentage. So it's definitely not the 18% he's got on top here. To get the denominator to be 100, we double 50, we times it by 2. If we times the bottom by 2, we've got to times the top by 2. So 18 times 2 is 36. So the fraction will be 36 over 100, meaning if we can then take the numerator as the percentage, so 36%. This means that the percentage of accurate is 36%, and that means Dora is correct. That was your explanation using the maths. Well done if you got it. If you started to get it and got some understanding, great. If you really didn't, that's okay. It's something we can talk about in our tutorials later this week. As with most of the maths lessons we do, what I want you to do is finish by going on your TT Rockstars and giving at least 10 minutes. I'd say 10 or 15 minutes is what I would like for you to practice the fluency of your times tables. Remember, every point you earn on it will add to our class battles and will help us to, if you're in my class, beat Miss Hartley's, and if you're in Miss Hartley's class, it'll help you beat mine. So finish your video, close it down, and then you can go on TT Rockstars, 10 or 15 minutes, and your maths is done for today. So well done, everyone, and I will see you tomorrow.